Good afternoon, all. Is it audible?
Yes,
Yes,
sir.
yes, sir.
Okay. And you can see our screen so that. Okay. So, so is it visible? Okay. Hello. Is it the screen is visible?
Yes, sir.
Yes, sir. Yes,
Yeah.
sir.
Okay.
Yes,
Okay.
sir.
Yes, sir. Yes, sir.
Okay. Fine. Fine. Okay. So, in continuation of this yesterday lecture, like last day lecture, that we are discussing about the supervised learning. So, what we have said that in case of supervised learning, two basic entities important. One is the data. What is the data? The data is set of records or data records, also called the instances or cases, described by some attributes. Okay. So in attributes means that the you can say the characteristics of the a particular classes. So K attributes means just for example, we just said about the apple. What is the color of apple? What is the weight of apple? What is the structure of the skin of the apple? So on, so on and so forth. And another thing is class. As another class that particular data or particular uh, instance is belongs to a particular group, and that called a class. Just for apple is a class, and these are the feature of the apples. So each example is labeled with a predefined class. So in supervised setting, these two is are very important. One is feature, and the feature is labeled by a data for a set of examples or set of, can say, instances which has been given a priority to the learning. So based on this labeled example, we're going to learn. And what is the goal? To learn a classification model from the data that can be used to predict the classes for the new cases. So the thing is that, let's say you had to say Apple, this is a classification or detection mechanism or a classifier, that a set of apples or a set of image of the apples have been given. And when a new image of the apple is being given at the time of testing, that how accurately your classifier is going to say, okay, this is apple based on the prior learning. And that is the goal, or that is the testing situation. So eventually there is two basic things. One is training that has been based on a given set of example called training example or leveled example. And after training, when a classifier is ready for being tested, a set of examples, this is testing sample, is being given to quantify or to measure the accuracy of your classifier. So that is the more or less the supervised setting. Okay. So here you can say supervised learning process in a two thing. One is learning, that's what I said. So learn a model using a training data. That's what I said. And testing, test the model using unseen test data to assess the model accuracy. Now you ask, so what do you mean by accuracy? Accuracy in general is basically measured by number of correct classification by the total number of test cases. So how accurately, how correctly? If it is a very close to the 100 test cases you give, and for 90% it gives the correct answer. So the 90% is the accuracy. So, and this is the way we are basically testing, we measure the testing accuracy. Right? So if we write a block diagram that there is a training data, then based on this training data means what? One thing is very much important. Since it is a supervised setting, we are saying the same line repeatedly, that this training data is a feature, is a labeled feature to a set of features or set of instances of a particular. And now the situation is not so always so easy. If you say the apple and non-apple, this is the one, a very easy or trivial classification of binary classification. Binary means there is a two class, apple class and non-apple class. Okay. But there may be a cases, there is a, you can see that there is a different number of classes. If you say, if you are going to say, we have shown a picture, that animal kingdom. So there is a different class as a birds, mammals, amphibian, reptiles, etc. So it can be possible a classification problem is basically for multiple classes. Then definitely the this classification process is bit complicated, but the settings is basically same. For each particular class, there is a set of examples are being given a priori for the training, and based on this, we have to say the these are the these particular instances or level instances from a particular class, and then maybe different number of classes. Okay, so this is the multiple class instances or test training data. But then we have to understand what do you mean by learning algorithm. What actually we learn. Okay, that is very important. That we're going to see in the corresponding and the your the subsequent slides. Okay, what do you mean by learning? Okay, then when the learning algorithm is done, we get a trained model. Okay, that model is being trained. Now this is very important. That what do you mean by a trained model? Okay, and that we'll discuss for a, just for your uh, understanding and just initialization of the technical aspects of, I'm saying what do you mean by model or what do you mean by training. Definitely this is very important concept, and we'll repeat this thing uh, at least twice or thrice. What do you mean by training of a classifier? Always see, in the most of the our setting, let's say very easy kind of linear regression or a neural network or a support vector machine. Now this model, what model we are uh, talking here, is a parametric model. And what are the parameters? There is a different kind of parameters. Let's say there's a weights. If you say the neural network is the weights of the your neurons, and bias parameter is there of the neurons. So for your understanding, that training means that we know correct value of the weight and biases of different neurons of a neural network, such that it can used or it can be classified our intended result. So that is important to understand here. Even if you set up for the linear regression setting also, we have to find out some sort of a parametric hypothesis function. This hypothesis function is again a parameters based or parametric function. And these parameters we have to know there to find out that when we give you a training data, it basically give you the right answer, what is given by a training sample. So training means there is a function, or there is a, this may be a model given by a set of parameters, and training means to know the parameters value so that our intended result the we can get. So that is been the training. So because I even after completion of the course, lot of people have been in our deep learning STEM or other different interview or other session, when we asked students that what do you mean by learning, they just say something differently. Learning means this. Okay, so that is very important and very first. This is not in a not in a time to understand all this, but just for your understanding, I'll say the training means this. Okay, then test. Now, testing is a kind of process where we know this learned parameter with us. Now, model is being trained means what? That means we have this parameter. Now, you see, even who are familiar with some deep neural network or something, today's a lot of students, a lot of people are knows from different internet level course that the different deep models. So something they saw the pretend model. The pretend model also very common term now. So what do we mean by pretend model? Pretend model means basically you know this parameter set. Okay, so this parameter set are known. That means that is the pretend model. Then you just fit the parameter model to your program or your model. You can get this model. So pretend model is something like that. So now with this pretend model, you are going to test the data. Which data? One important thing is that at the training phase, there is some sort of training sample by which you are going to train your classifier. But at the testing sample, this testing sample are generally different than the training sample. But one thing, the data distribution likely to be from a similar distribution. Okay, it is not that it is an assumption. We'll show in some next slides, next few slides, that this distribution of the data distribution, the samples you are being taken from the training samples or the testing sample, the data distributions are more or less same. And then we measure the accuracy, that you know what is accuracy. So this is the basic process of supervised learning. Generally two steps. One is learning or training, another is testing. Okay. So if you have any question, ask. Otherwise, it's a very simple thing, just definition I'm saying. So okay. So that we are basically saying. So what is the assumption of learning? The distribution of training examples is identical to the distribution of the test examples. This is a assumption, including the future unseen examples. Okay, the distribution of the training example is identical to the distribution of the testing example. Means that the data, as I just explained, the data which is used as the leveled example for training purpose, that we are taking the similar data from the similar data distribution. So density function, distribution function is somewhat the same. Okay. In practice, this assumption is often violated to a certain degree. Yeah, that is also a very important aspect, because when we go to understand the different, can say, more complicated aspect of machine learning, that this assumption is a very interesting assumption. Okay, so in practice, it is not always the true. Or sometimes you can say that we train on a particular data set and you testing for another particular data distribution or some type. Not, I'm not saying completely different, but to some extent different. Then you can see that how actually your data, your learning is. So here you can see the strong violation will clearly or certainly result in a poor classification accuracy. That is very sure, because it data is a completely different data distribution. Obviously, it will fail to classify. But sometimes it is based on some sort of design criteria. We'll see later that how your classifier is well generalized. So there is a question of generalization. We'll see later in our discussion, so that how generically we can access or we can classify the data. To achieve good accuracy on the test data, training example must be sufficiently representative of the test data. And that is very important. Now,
Excuse
what
me,
does this
sir.
mean? Yes.
Sir, can we just not achieve this by, say, getting suppose 100 samples and randomly picking out 50 samples for training and 50 samples for testing? That way it will be representative easily.
Yes, yes, that is why that is the way we actually do. But not exactly 50-50. We generally take 70 or 75 samples for training and 20-25 samples, 25-30 samples for testing.
But then how is this violated? I mean, in practice, how is this violated, sir?
No, no, no. I'm not saying that. I've said now if it is done, there is no valuation at all. But you can say that you have a two different data set. Just for example, I am giving that you are taking some sort of let's say uh, images of birds. Okay. Now you train your classifier with your grayscale image of bird, and now you're testing your classifier with a color image of birds. Both are birds, but you never use a single color image of bird for your training. But at the testing phase, you are giving the kind of uh, ex- uh, images from different domain. So then this kind of problem may happen. The classification may not be that much good. Getting the point?
Yes.
Hmm. So this is a very important. So that's why this question or this particular way I put trace in this, because there is a lot of important concept actually associated with this particular point. Because when we'll be more familiar with the more complicated situation, it's called domain adaptation. So it's a different domain images when that, and there is a domain shift, domain adaptation, how we handle the domain adaptation, all these things will come. So that is a different are not in within all our scope of this particular machine learning. When we go for some other deep learning or kind of geosort learning or few sort learning, then these questions come in a very prominent way. So I'm not going to that far now. Okay. Okay, let's take an example. Now it is a regression example, but when I take as a supervised learning as a now it's a housing price prediction. Now here you can see that this crosses. What does this crosses means? This crosses is basically a two-dimensional data point for it's a training example. Now, what do we mean by training example? Training example means that now you can understand very clearly. You can say, what is the x-axis? X-axis is the size of feet square. That means the size of your house. And y-axis, it is in a price in the dollar. It is in scale of $1,000. So every crosses will give you this is the size of this house and what is the letter. If you just draw a line from the y-axis, you get the corresponding price. Now the question is that these are the data samples. Now what is the dimensionality? There's a two-dimensional data. One is the size on feet square and is price. Okay, so this is the kind of training samples are being given. Now question is that what actually want to do in a supervised learning in a under this linear regression example, that now if there is a cross in between these two crosses. Okay, so let's say here this is the cross. So what if this is the your data samples? So any point in between cross, can you do that for you as a testing data? Because training data is given, testing data in between something somewhere else, because infinitely number of data can be given. This is the problem. So what you want, you will going to do that the thing is that. So can anybody answer this question? If this on this the problem is given, what you want to do to getting a um, price of a unknown size that is not within this process?
We can fit a curve y equals to mx plus b kind of.
Yes, very good. So this is, it's a very trivial kind of thing, but it's very good answer. So this is, we write a curve. Okay. But what is that curve means, that what is the nature of this curve, that I'm not saying. Let's it's a straight line. So now the this curve, what he suggested, that y is equal to mx plus c, that so this is so this m and c, y is equal to mx plus c, m and c is a parameter. Now what I said earlier, that a function, and in next slide we'll say that, next slide we'll say that is called hypothesis function. That's a parametric function. And what is the parameter? This m and c. Okay, so in this particular thing, we had find out that, okay, can it be possible to draw a line, just for sake of, as a simplicity, line, so that we can represent these data points with some accuracy by this straight line. So what do you mean by representing accurately these points? Now the question is that if we try to represent this point accurately, the distance of these data points and the corresponding data point within this line of this corresponding x-axis position will be minimum. So this distance, this vertical distance, okay, should be minimum. Okay, that means in for all the data points, if you average it out, that what is the average distance of the all the respective data points from the corresponding data points on the line. So that means how the point on the line for a particular corresponding, how it is differ. And if sum it up, then you can get a kind of loss or kind of deviation. And that deviation, if you can minimize, then that much accuracy you can get for this particular thing. So I'm coming with all this. Okay, now before that, we have a question. So what, that may be straight line, but if we write this kind of a curvature or curve, you can say, so then that curve may be more, you can say, accurate rather than a straight line. So what is important here, there's a lot of issues which is being associated. Now we can get a linear. Now you can say, sir, we want only straight line. You can say it. That maybe, so straight line is good enough, but the problem is that that may not be that much accurate for the to represent the data point. Okay, but the complexity of the curve or a hypothesis function is in general linear. That is one good, is easy to implement. Complexity is less. On the other hand, you can go for a complex curve. Now this complex curve, maybe its complexity is a bit high, but the accuracy also will get a bit higher. So there is a question, this trade-off between a model complexity and the accuracy of the representation. Okay, so that is very important, that we'll see later when we'll see that these overfitting, underfitting, and kind of model accuracy trade-offs. So I'm not going to say all these things here, but this is the way, I just pointing it out so that you can think in that way. Now what we can say, that this is this kind of thing is called the curve fitting. That is very trivial concept in our basically 10+2 or your engineering mathematics. Okay, this is called the linear regression, because if this particular is linear in nature, it is basically a curve fitting, because if it is a non-linear or something like that. Okay, so any questions on that? Okay, and one thing we are very much with, that in this case our learning paradigm is a supervised learning paradigm. So we are, whatever we are doing based on giving some examples. So now you see, when it is being trained, what do we mean by trained here? What that then we know this line. Maybe what is this curve, the green curve or a red straight line. But trend means when we know the lines. Now lines means what? Lines means you know M and C in case of straight line. That parameter value you know. Now you are satisfied with your line. Okay, that means this line is you can think it is good enough to represent our training data. What is the given data? And we know the M and C. Now, if you know the M and C, now any point here, if you have this line in any point x-axis, you can get a corresponding y. If any the size of this your house, you can get the corresponding y. Okay, but it definitely it depends that how accurately your curve, that may be line, maybe curve, maybe anything, that based on your model complexity, how accurately it represents your data points. But whatever is the case, if you know this curve or know this line, you definitely have to have. So this is the testing result. Any data you can get a corresponding x-axis and corresponding y-axis. So you given x-axis, you get a corresponding y-axis. So that means how close to your actual data, it depends on your model accuracy. But it means the training, your classifier is trained. Not should not say classifier, your regressor is trained. Another important thing. So what do you mean by regression? Why I'm saying not classification? Why is there a regression? One thing is very important to know, the difference between regression and classification. If your output value, since what is your output? The price of the house. This is the output. And what is the input? The size of your house in a square feet. Now, if this your y-axis, that means output of is continuous in nature, it is called regression problem. And if this y-axis or output is discrete in nature, that means apple or not apple. Okay, or maybe is it kind of bird or non-bird, or birds, or you can say amphibian, something like that. So discrete in nature, then in general we say it's a classification problem. And if it is a continuous in nature, we call it a regression problem. But must remember y-axis, that means what is the output is concerned, not input. Okay, so this is the definition, because a lot of people say that they can't say that what is the difference between regression and classification, even in a supervised setting. That is important. Okay, now I give the example of classification here. Now you see there is a two set of points. Okay, and if you just give a projection in a single line, you can say that we can easily find out that based on the size or something like this, in any kind of this, that we can differentiate between a two clusters. This red is one thing, it is within this, that may be outlier or is kindly misclassified, but it is a very common case, because every data points can be accurately classified, it may not always be the case. So the classification is discrete values output, 0 or 1 is a binary classification, multi-class classification also can be possible. So the question is that fruit is apple or not. So here you can say, but this data is a single dimensional data, so that we can get in this way. Now it's a two-dimensional data. You can say that the example we given is just last class. Now you see that this is an example. First, this is a given example. The red are apples, let's say red triangles are apple and green triangles are not apple. Okay. Now, what is important here? Now, how you are going to classify? You are going to classify, you put a kind of separator. We'll say that in our future uh, slides or future classes, we say this separator as a decision boundary, which decides that this set of data can be separated from this set of data, and this set of data is given as a apple, and this set of data is given as a non-apple based on your given supervised, you can say, training example or leveled training example. And what are the different features? There may be a color is a feature, texture is a feature, cost is a feature, and in so many features. But in this example, what can say, the feature space is is a weight and size. These are the two-dimensional features. That is very easy for drawing. So these data points are a two-dimensional data point. But you can say, so it may be an n-dimensional feature point, n-dimensional data space or feature space, where each data point is a n-dimensional vector or n-dimensional uh, data. And then generally say that this in this n-dimensional data, this is the point clouds which have been clustered or clustered together. So this is the thing. So you just imagine in a higher dimensional cases, not always only two dimensional. In general, we have a very high dimensional data space or feature space. Okay, so this is a classic example of classification where we try to find out this fruit is apple or not by this. And generally, this is for a very easy example. So this separator line is a linear in, and you can say these data points are linearly separated data points, but not always, because you can say if you want to separate it this green and red in this way, that may be some sort of nonlinear decision boundary can be possible. Okay, just for example, if I just for yeah that I so it can be possible in this way. Just if you say no, okay sir, I am going to very keen, so we can write in this way. This may be your separator. Now you see that your separator is perfectly classify this red triangle and green triangle. But one thing is important, this separator is a very much complex curve, not a linear separator or a very or better separator with a lesser complexity. Okay. So if for a high dimensional cases, in general, these separators are called hyperplanes. Okay, so it's called hyperplanes, and in general, hyperplanes is the one dimension lesser than the actual dimension of the feature space. So if you have any question, you can ask. Otherwise, this is generally is a very simple example. Now, what to whatever we have discussed so far, it was supervised setting. That means that these examples is given in this way, red and green. Okay, but now if there is no level, then we can say this is unsupervised. So the question is that we are given in this. So here something we can say in this way. Actually, that you can say that these data points are same data points are being given, but there is there is no way to separate this. Only if you say that okay, this is a point here and this is a point here. Let's say this is some sort of center point, and the distance of this particular fellow, if you say, is generally less to this center rather this center. Okay. So in that sense, so this particular object instance is belongs to these. If you say this cluster, I'm going to say that this is the cluster. So this particular example or instance is belong to this cluster. So because it is close, the Euclidean distance also you can analyze that. So in from this Euclidean distance, if you say that this cluster center, this particular object instance is closer to this cluster center rather this cluster center. So that is the thing. And based on this, we can group it to different cluster centers. Getting the point? If this is the case, now one thing is very much understood. Now this data distribution, based on this data distribution, you can say, or grouping of the data, this the we can say now it may be possible that that may be possible. There is another kind of, this is a I'm sorry, I should not write it in this way. So here also similar data. So I'm not just let's assume that these are all the same thing data and something like that, and then you can get another cluster here. That may be possible. Is it two binary, two clusters? Is it three clusters? So any other cluster is possible. So if this is the case, if we don't have the level example a priori, then we call it the unsupervised setting. Okay. So this is we try to understand. So this is some algorithm we are going to see that clusters or group in this way. So what is the difference between supervised? What we have seen in case of supervised setting, that this supervised learning discovers pattern in the data that relate data attributes to the target attribute. These patterns are then utilized to predict the values of the target attribute in the future data instances. So it find a relation, find a function with given a set of attributes with a set of class that maps, that actually that particular function is maps between these two entities. But in the unsupervised setting or unsupervised learning, the data have no target attributes, so the level is not there. So we want to explore the data to find, or you consider to find some intrinsic structure in them. So intrinsic structure means what? This is intrinsic structure, that these data points are closely grouped. You can say the closely clouds, sorry, closely related. So with this background, we just define the clustering. What is the one of the very popular unsupervised learning techniques or learning methods. So clustering is a technique for finding a similarity groups in the data. What exactly we have shown in the example? It groups the data instances that are similar to near. Similar means what? Here, their similarity feature is basically it is near to a particular data cluster center, to near to each other in one cluster, and data instances that are very different, so far away from the other cluster in the different clusters, or each other into different clusters. Okay, so that is exactly we are trying to say here. This particular, again, let's say this particular fellow is basically close to this cluster center, rather here or rather any cluster center here. So this distance, these two distance are high than this distance. So it belongs to this cluster. That's all. And that is this Euclidean distance in this case is basically the deciding criteria, distinguishing characteristics. Okay. So clustering is often called unsupervised learning task, and no class values are denoting a priori grouping of the data instance are given, which is case in the supervised learning. So in that way, it is different than supervised learning. So no a priori information or leveling information is given. So due to historical reason, clustering is often considered as synonyms with unsupervised learning. It is very, we generally use the clustering and classification as one is unsupervised, clustering is unsupervised, and classification is supervised. In fact, association rule mining is also unsupervised. That is also a good example. So that is very important to understand for you that what is basically clustering and what is this is a typical example of unsupervised learning and what is the basic difference between unsupervised supervised learning. This example, again, another similar example is being given. So you can say we can get a free cluster out of this depending on the data distribution of a pattern or kind of pattern the data. And this is some examples or applications that what we say what is the clustering for animal kingdom. Now here also one thing that fishes, if you say that how you are differencing it, the fishes is underwater, bird can fly, amphibians at those, it is what did it say, yeah, this frog or kind of thing, both in water and land. Then reptiles who have no, have that as a typical walking pattern. Mammals is, these are the mammals of these examples of the humans and mammals. So in this way, some basically basic patterns or that some basic characteristics is or you can say characterizing feature with these animals and which make it from a particular cluster, the fish cluster, bird cluster, amphibian cluster, reptile cluster, mammal and so on. Okay, here also one another typical example when you write some this this is a very more common example when we search okay IPL. So this IPL is basically we search in IPL. So lots of IPL related things will come in your Google box. This is also a kind of because Google has a plenty of news, different, but it clusters. The IPL means it's a cricket tournament. It is in generally held in India. It's a and this example I'm taken long back actually. So, but still it's giving this way that IPL these are the events. So if you go there, so these are the different information when going to get. So one thing is important that to understand. So these some data or some feature, let's say it's a cricket related, some common names, some common teams, some common jersey colors, some common kind of popular characters. So these are the some popular words. Okay, so these are batting, bowling, fielding. These are the very common words, and the century and kind of half century. These are the common words. It makes the particular news articles. Let cluster it in this. So I feel these are the maybe 10 lakhs or 50 lakhs news articles will cluster in this. If you have more IPL 2021, okay, so then okay, so I not only it is a subcluster, okay, in between the IPL, not only IPL, then 2021 IPLs will come up. Okay, so these are the some general Examples of clustering. Genome clustering, the gene expression clustering is a very, very useful. Okay? So how actually we clusters different genes based on the different characteristics. It's a huge task. It's a huge thing. It's a lot of characteristics depending on the different protein positioning and are typical uh, in a gene sequence. So this gene expression clustering is also a very, very popular. Even this particular thing is almost a, you can say, another subject. Okay, genome sequencing is important. So a lot of applications. So organizing computer clusters is one. Social network analysis. Now social network analysis, or now it's not analysis, it's become a mining. Social network mining or social media mining is becoming a very popular topic in machine learning techniques, and lot of things is being done. That sentimental analysis of a person, of a group, or any kind of subscribers and users and anything, some buyer. So all these things can be done. So it's a very, very well, it's a big data analytics kind of very popular topic. Market segmentation also a very, very important topic in, with associated with finance and marketing and consumerism. So that thing is a very important aspect, because if how to know that a particular, if you say that you are going to launch a particular company, so some startups you want, so you have to first to attend the product you are basically looking for, or basically trying to give the market, how it is going to going to be, you can say, how it is more popular, how it is being accepted at the market. So it's the market side where market segmentation is very important. Let's say if you are going to kind of a particular app, now we have to say that if it is a kind of, let's say it's a drawing app. So is there any kind of drawing app, or what is it is basically, what is the basic quality of this app? Okay, then how, which portion of the customer, or these people who are going to take, what is the advantage of your app, what is the special criteria for that nobody can give, or you can say there's the Indianized version. So how these generally these drawing kind of things are very, very costly, and if you, there is no that much Indian product is there. So this kind of lot of issues, I'm not that domain person, but these are the issues are basically there nowadays. In most of our project is very much this kind of, that we have to kind of a product oriented research. So nowadays in IIT level, this kind of concept are very popular, that product oriented research is required. So we are also trying to understand all these things, that when we write a patent or write a project, how it is, how, what is the sellability, how much profit we can generate it, or a particular concern, if it is given by some government concern, how much profit they can get out of it, how much financial benefit they will get. So this kind of market research, market segmentation is very important. For in general, we are not a very rare, definitely expert on this, as we are a very much academic research minded, but it is required nowadays. Okay, that people are doing all these things. Now, another thing is astronomical image and data analysis kind of thing. This is also a very important aspect, that we are nowadays, we are very, that you can see that our art is going to be maybe due to some pollution, due to other some greenhouse gases, it become inhabitable for the next let's say 500 years or 1,000 years back. May not be human is not, and the art is not very that much habitable for the humans. So NASA and other basically these basically institutes try to find out but habitable, you can say, our planet nearby um, solar systems. Solar sun, so not solar is other kind of systems. So there's a lot of analysis and lots of astronomical data, image, video is being taken. So this is a huge thing. Speaker recognition and lot of things are basically. So okay, we'll discuss this, and this we are almost close to our introduction. Only next thing is reinforcement learning that we'll discuss in the next class tomorrow. So thank you very much for your attention.